So here we'll look at some of the issues when all of a sudden you're trying to create a good model, or when you're taking a look at data that's already been presented to you. Well, the first thing that we're all pretty familiar with is causation, where you have the direct cause and effect between some variables. So, for example, maybe the amount of artificial sweetener in this rat's diet versus the number of tumors in the rat's bladder. So, what we would see is that the sweeteners have a tendency to cause the tumors. But the issue with causation, it gets thrown out there quite a bit in the real world, but it's very, very hard to conclude without a very, very carefully controlled experiment. So, for example, one of the big things are these ideas about lurking variables. So it's not an explanatory variable. So remember, that's x, right? So an explanatory variable, that's x, right? Here's the explanatory. And then the response variable is y. So, for example, here's a situation where the number of ministers in Boston, as that's been increasing, so has the number of barrels of rum sold. So all of a sudden, we have what looks like a very, very strong relationship. But is it enough to say that there's some kind of causation where the ministers are causing the consumption of rum to increase at a pretty linear and pretty positive rate? Obviously, that's not the case. So when we think about lurking variables, what we need to look at now, is there some other variable? It's not the number of ministers, it's not the barrels of rum sold, but it could be responsible for changes. Here's the big thing, in both variables. And here, if you think about it, population, right? Population. As population has gone up, ministers have gone up, and so has the number of barrels of rum being sold, right? So population here, although we don't see it in the graph, is actually lurking kind of behind the scenes as the real driving force, and it's the one that's responsible for the changes. So all this to start this conversation off, that correlation does not imply causation. People will try to show you that there's some type of relationship that's occurring and try to claim that there's causation. But as we can see here, the number of ministers is not causing the barrels of rum to increase. The population is what's causing these things to go up. This lurking variable that isn't even really accounted for. So what's this called? When you have a lurking variable, you end up with something that's called common response, where you get changes in both x and y because of some third variable, z. So what's happening is creating an association even though there may be no direct link between x and y. Again, if we go back, there wasn't really a direct link between the number of ministers and the barrels of rum sold. Here is population, your lurking variable is causing a common response. So another way to look at this, let's say we have a high school senior's SAT scores, which typically are a pretty good indicator of first year college GPA. But is there some type of lurking variable, right, that causes a common response? So lurking variables cause this thing that's called a common response to occur. So in other words, is there this variable z in this situation that would cause both of those to change? For example, maybe their study habits. Typically, if you study harder, you're probably going to have SAT scores that are higher, and you're probably going to be better in school. If you're just a smarter person, right? We all know somebody that never has to study, yet somehow they keep getting good grades and they do well on their tests, and that's just natural ability, right? Work ethic could be one of those, right? People that work harder, so on and so forth. Right? Now, there's this other type of variable, which is called a confounding. And this is a little bit different twist to a type of variable that could also be kind of behind the scenes. So this isn't a lurking variable, right? Lurking variable causes changes in both. A confounding variable, the big thing here, it's related to group membership and can also cause a response, but is not considered. Another way to think about this is we have another common characteristic of the population that can end up causing the response. So there's a study done probably back in the 90s about typically people that attended church or some type of religious service tended to have a longer lifespan. So the way that confounding works is that you have the situation where we need some type of effect on y But the issue here, there's still some type of connection between X and Z. So in other words, our population of interest are religious people, right? So we need another characteristic of this group that could also explain living longer, right? So one of the characteristics that we're looking at, well, they tend to go to church or they tend to go to some type of religious service. Well, another thing that could be causing this, again, it has to be related to group membership. Maybe these religious people just have a healthier lifestyle, right? Maybe their religious convictions, they don't drink, they don't smoke. Maybe they're less likely to take risks, right? These religious people. Other thoughts that came up today, these people that are typically attending these religious services might not have as much stress in their lives, which could also lead to a longer life. Right? So let's look at some things here. Do we have some causation? Do we have a common response? So here, again, you're looking, is there a lurking variable? Or is there a confounding variable? What does TV make you live longer? So typically, if there's more TVs, uh, longer life. So we think there's obviously other things that could affect these. And if we think about that, typically, nations that have a lot of TVs and have higher life expectancies probably also have a tendency to have a lot of money. So that money could affect both of these. So here's a situation where money is a lurking variable, right? So it's causing a common response, right? Right? Common response, rich nations have more TV sets, so they're going to have longer life expectancies as well. So the lurking variable would be money, potentially, or living conditions is another one, if you can kind of see past all the garbage at the bottom, right? If you think, right? Probably typically countries that have a little bit better, higher standard of living, right? Standard of living. All right, it's really sloppy to get it in there, but standard of living. They probably have more TVs. They probably have longer lives. So here, standard of living could be a lurking variable causing a common response. Here's a situation. Does exposure to chemicals cause miscarriages? So a study has shown that women who work in production of computer chips have a lot of miscarriages. The union is claiming that exposure to chemicals, so these women exposed to chemicals, women exposed, there's a situation where they're having more miscarriages. So we're trying to figure out, and if we look here, they give us another possible explanation. These workers spend most of their time standing up. So standing. So we're trying to figure out, is this a situation where we have a lurking variable, right? Do we have a lurking variable? Can we say that, well, it definitely is causation? Well, they haven't done a carefully, controlled experiment. So are we looking for a lurking variable causing a common response or a confounding variable? So here we can see this group of women that is standing, it's another characteristic of these women that are on the line that's also causing the miscarriage. So this is a great example of confounding. Because again, this is a characteristic of the original group, right? These women are exposed to chemicals, but those women on the line are also standing up. So it's a common characteristic between the two groups. So this would be a lurking variable. Our grades in TV watching link. Children who watch many hours of TV get lower grades. So does more TV cause lower grades? Obviously, they have not set up a carefully controlled experiment where they're like forcing kids to watch TV and then taking a look at their grades. We're trying to think, is there something else that could explain both of these, where they would maybe be watching more TV and have lower grades? And I would make the argument that maybe, again, socioeconomic level, maybe if there's not as much money in the house, they have a tendency to watch more TV and then their grades would be lower, right? Maybe another thing, well, typically, in my experience, think about this, parental involvement. If parents are more involved, they're probably not watching as much TV. And also parental involvement. This is just my experience in education. Typically, students with lower grades, and I'm talking about very, very low grades, don't have parents that are as involved. This is something where you guys are all pretty lucky. You have parents that are very involved and very invested in what you do. This parental involvement could cause a change in both of them, right? So this would be a great chance to look at a lurking variable. So the lurking variable here, parental involvement. Maybe it's socioeconomic level, right? Lurking variable, right? Ice cream and the flu. There's a negative correlation between the number of flu cases reported each week throughout the year and the amount of ice cream sold. So does, right? Negative correlation between the number of flu cases and the amount of ice cream. So does the amount of ice cream affect how much flu is out there? Well, this is one, again, if we were to kind of think about this for just a minute, as more ice cream is consumed, typically the amount of flu that's out there is probably going down, but that has nothing to do with the flu. It's not like, oh, well, after the flu, I can't eat ice cream. If we think about this, typically what happens in the winter, people eat less ice cream and there's more flu. So here all of a sudden, right, the season, let me spell this right. I realize a lot of these are hard to see and I apologize for this, right? Think about it. In the summertime, as ice cream consumption goes up, the occurrence of flu goes down. Or if you think about winter, as flu is going up, the occurrences of flu, not a lot of people are out having a nice cone of ice cream in the dead of winter. The season here would be a great lurking variable that's causing a common response. All right. In terms of confounding, we'd have to try to think, is there another common characteristic of ice cream eaters that causes the flu? And I can't really think of any. So this is a great chance to kind of look at a potential lurking variable. Right? And then take a look at one more. Raising SAT scores. A study finds that high school students who take the SAT, enroll in a coaching course, and then take it again have a decent jump in their scores. So, so the group of interest here. So we're looking at the response was an increase in scores. Right? Scores have gone up. So second time after course. So could you come up with a common response situation, or could you come up with a confounding? Well, probably if you have the ability to take it a second time, you might have a little bit more time, or you might have a little bit more money, which could lead to better scores because maybe you have access to more, right? You have access to the ability to take it a second time. You might have access to other means to help improve your scores. Here I'm kind of thinking about a confounding variable. Do you think, right? We think about, is there another characteristic, these people that take it a second time, that might also lead to higher scores? Well, I would guess if you're taking the test for the second time, you might also just be familiar with the test, right? This group that's taking the test for the second time, they might just be more familiar with it, right? So second time, they're more familiar, right? It's a new version of the SAT, more familiar. That could also cause an increase in score. So here's a good chance to look at a confounding variable. This group of second-time students, it might just be a matter they're more familiar. Maybe this group of second-time students have had more math classes, right? This is 6 months to a year later, so they've been exposed to more math material. So here's another common characteristic that we can maybe throw out there, where those second-time students just they have more access to math material.